Hello everyone, my name is Timothy Lee Grant. So I decided that I am going to try to change up my LeetCoding coding strategy and see if this method helps me move forward quicker in the LeetCoding coding process. So what I'm going to try to do is just focus on, again, I've been focusing on one topic, but what I'm going to try to do instead is just really understand how one problem, two problem, three problem, and just really try to focus on getting one topic, going through each question, and just not even trying to do the problem itself initially, but rather just look at the answer, try to figure out what's going on, try to understand, okay, well, what is the connection between this method of solving a problem, and here's an example of a problem that it solves. So I'm going to be going through in this video the questions which I was dealing with today, how I went through and solved them, some of the stumbling points which I had, some of the things that I need to focus on and improve and clarify in my own head, and then try to see, like, build a better and better and better process for moving forward with LeetCode. So here are the ones that I did today. I did those right there. So longest palindrome, containing or container with most water, threesome, and threesome closest. So as I said, I didn't just like go into it and try randomly to do the problem or to conquer this problem. But I went to it, I read the problem, I looked at it, I thought, like, can I solve it? Can I not? And then wrote down in a notebook, like, okay, what do I think the connection is? I know that it's two pointers because it's in the, I purposefully selected the two pointers section. So I knew that it was two pointers. So I wrote in my little notebook about how, okay, well, here's the kind of question. The question is talking about an array. So let's, I guess I can come here. So I went to this one, right? And I said, okay, so number 5, longest palindromic substring. Given a string S, return the longest palindromic substring in S. All right? So the first thing that I notice is, okay, so two pointers can solve things such as strings. Now, strings are essentially arrays, right? They're character arrays. So, okay, so this method of solving problems, two pointers, is useful for arrays, and strings are just a specialized version of arrays. Okay, so what is it actually trying to have me do? Well, it wants me to find kind of symmetry. So there's this that indicates that, okay, the two pointers method is a good way to find symmetry. Well, how would you do that? You would start in the middle, use two pointers to kind of expand, 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 and notice each time I expand out, I'm able to verify that, yeah, these two things are indeed the same element. So you can find symmetry with that. So a couple points that I was tripped up on, though, was right here when you actually need to go and try to check um, the even case and the odd case. So that indicates that there is what, a difference in starting point. So what it is talking about is, like, if I start my two pointers on the same location, right, and then kind of radiate outwards, then I'm going to have an even length, or sorry, an odd length, because they're first starting here, so there's of length 1, and then you add 2. So each time that you radiate out, both pointers move, so you get a +2. So now that also kind of reinforced in me, okay, well, the each operation you can either move once or twice, right? Because you have two pointers. One pointer can move and the other one stays fixed, or both of them move at the same time. Okay, so in this case, because both are moving at the same time, you're going to have the length increase by 2 each time. Now, if you start in the middle, it is odd, right? Because there's 1 and then 3, and then um, you're able to like continue radiating out, but you never hit an even number because you're always just doing odd plus 2, odd plus 2, odd plus 2, right? So, okay, well, then the question would be thinking, all right, well, what if in this case we have an even number, right? Well, how do we do that? Well, you would need to start at 2. So instead of starting right here in the middle, right, that wouldn't make much sense. You can start where one pointer is on this B and the other pointer is on the other B. Well, okay, how do you do that? Well, that's just setting. Where do I actually do that? So that's length. All right, so here's where we set left and right. So this one, we're actually setting it to the same one. So I think I actually made a mistake there. So because this one is going to be left and right are on the same one, which is I. And so this for I in range, right? So what we're doing is we're going and we're looping through each of these elements, and each time we go through this for loop, we are identifying one letter or one array element or one element or I keep trying to think of like, okay, well, how do I actually say this in so many different ways that it kind of sticks in my brain to be a little bit more generalized. So each time I go through, I'm going to go through this bam, 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 bam. And each time I am going to try to radiate outwards. Now, I can radiate here where I pick both at the same time and then radiate outwards. That's this one, okay? So this actually I think should be even because I'm starting at the 1 and then going here and then going there. Or what I can do is I can have left is equal to I, which I will be here, okay, at first, and then I plus 1, which is that one. Okay, but I plus 1, that kind of hits in my head that it's possible that we go and hit an index outside the bounds of the array problem. And the reason that I'm thinking about that is because, okay, well, I know that I here is within the bounds of the array, but now I'm doing I plus 1. That's not guaranteed because eventually we're going to get up to this point here, the D, where it's outside that bounds. Well, okay, how do I actually make sure that I don't hit that? Well, it's this one right here, which is I verify that, okay, this right pointer is less than the length. If it's not less than the length, if it's equal to the length, then I don't want to go and even try to index it right there. So, okay, that's how I was doing that. Now, what actually goes on in here? So, let's see, what was I up to? Reading this note, I don't need to, all All right, another point was this one right here is I was trying to figure out why this was r plus 1 instead of just like L to R, but this is because when you're doing the slicing, the last element is not included. So that's something to just kind of keep in mind. And let's see, length is okay, so this one right here, length is as we're radiating out, this right here, this while loop checks the condition that it's a palindrome, right? So if we're in here, it is a palindrome. Sorry, if we're in here, it is a palindrome. So we can check if the length is greater than the current maximum. So another thing that I was looking at was, okay, well, with 2 pointers, you can kind of determine the length with the left and right pointers themselves, right? And if you think about it, it's obvious, but it wasn't obvious to me because I didn't immediately click, or like I didn't think of it until I explicitly said so. So, okay, if I never ever need to figure out the length when I'm using 2 pointers, okay, all I need to do is take the left and minus the right. Okay. Um, so why did I do the plus 1? I actually don't know. I guess that's something that I need to go back and try to investigate right there. Um, so then I see if it's longer than the current max. If it is, I update current max, and then I do the slicing. And then I just use these 2-pointer method to radiate outward. So left goes over by 1, right goes over by 1 in their respective locations. So this is kind of the radiating out part, and both are moving at the same time. Oh, I remember what the current length plus equals 2. So this is the way that I was trying to do it in the past. I was trying to do like current length plus equals 2, so each time increasing the current length. But then I realized, hey, I don't even need to do that. I can just find the length directly by the distance. And then doing the exact same thing for the even case. So that was this problem. The other one here was contains the most water. So this one was kind of interesting. So you're given an array, an integer array height of length n. There are n vertical lines drawn such that the 2 endpoints of the ith line are I of 0 and I of height of I. Find 2 lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water that can be stored. So again, what are some observations that I can make on this problem? Because I know that 2 pointers is involved. Well, it's an array again. Okay, so arrays, if I get a problem that has an array, I should be thinking that 2 pointers might be involved. So it should be something in my head. Okay, I see an array problem. I should think, is there any way for me to use 2 pointers? Method. The other thing that I see is 2 pointers allows me to keep relation of the respective position in the array. So in this problem, the position, index 1 and index whatever this is, 8, actually matter because that's the width. So if I need to keep track of positional data and positional information, and that has something to do with the problem itself, that should indicate to me some idea that I need to use 2 pointers. So, okay, well, I was thinking about this problem, and I wasn't quite sure how to do it immediately, but then I started thinking about, okay, well, I know that the width, I want to maximize the width and maximize the height. So if I have 2 pointers, where do I want them to start? Do I want them to start inwards? Well, no, because that's the minimum height, or that's the minimum width. I want the maximum. So I'm going to start way over here. Like one left is going to be over here, right is going to be over here. Okay, and then if I have to, I'll move them closer. No, all right. Well, okay, what would be a condition that I move them closer? Well, I want to try to lower, or I want to get rid of the lower pole. And what I mean by that is, like, let's say that I have a pointer here. I'm looking at this pole and I'm looking at this pole, right? The water is this high right here. Well, this pole is limiting the amount of water that I can do. So if I'm going to shrink my base, which one should I shrink? Should I get rid of this one or should I get rid of this one and move over here? Well, I want to get rid of the limiting one. So if I have to get rid of a pole, I'm going to get rid of the limiting one. So I go a little bit less in the width, okay? But I'm either going to increase or decrease this pole height. In this case, it increased it. If it decreased it, well, then I'm just going to continue to move on. Move to the next one, move to the next one and I'm going to constantly just go away from the limiting pole. So, okay, I have this big pole. Now I find the volume in there. All right, that's cool. So then I take account of that. I'll say like, hey, this is my current maximum that I found. And then I want to get rid of the limiting pole, which is which one? It's this one right here. So now I'm going to go and investigate this one matched with this one, which here's the volume there. I'm going to see if that's higher than my current max, which it's not. And then I'm going to get rid of the limiting one, which is this one. So then I'm going to look at this one. Like that. And then these two are equal. I can get rid of either one that I want. So I move here, move there, move there, move there. And then once they're at the same pole, there's no volume at all. So that's kind of how I did here. Left is less than right. Now, how did I come to that conclusion that it should be less than and not less than and equal to? Well, if left is here, right is there, once they get to the same location, it's kind of over because you have no volume anyways. So that's how I made that judgment. I find the current volume by taking the minimum of both of the heights of the left and right pole. And why is it the minimum? Well, that's because if I have this pole right here and this pole right here, it doesn't matter how high this pole is because I'm being limited by this one right there. So I take the minimum and multiply it by the width, which again, this makes another connection back to the last problem. Remember how I said 2 pointers allows you to keep track of positional data inherently with the left and the right, which is here, left minus right. I'm able to keep track of the width just by looking at the left and the right positions. Okay, so then I check if it's larger than the current largest volume. If it is, I put it in there. And then here is where I decide to move. So, okay, I just checked. Here's these 2 poles, right? Maybe this one is small and this one's large. Okay, which pole is the smallest? Which one is my limiting one? Well, it's this one over here, so I'm going to move over and get to the next one. So I'm going to get rid of the limiting pole. So if the height of L, height of my left one is smaller, I'm going to be moving left over by 1. Otherwise, I move my right over by 1 in the opposite direction. Okay? So going back over this problem, what did I find? Okay, 2 pointers is useful for arrays where you're trying to find a relationship between multiple, in this case two indices. Okay, so it also gives you like relational data between one and another, so they're connected in some way. Okay, it has the left minus right, which says, hey, there's distance between them, positional distance. All right, so let's go back to here and let's look at threesum. All right, so threesum is this one right here is going to be given an integer array nums. Oh my goodness, we have another array. Okay, so now we're starting to see a little bit of a pattern. It's an array, an array, an array. Later on, we're going to see, oh, actually, you can do more than just arrays. But anyways, right now, array. 2 pointers. Okay. Return all triplets, nums of I, nums of j, nums of k, such that I does not equal j, I does not equal k, and j does not equal k. And nums of I plus nums of j plus nums of k equals to 0. So back to that point that I just made in the last one that I was talking about, well, it has relational data, like how one relates to another. In the last problem, there was only 2 that I was concerned about their relationship. Now there's actually 3 separate indices that I want to know their relationship with each other. Okay, so if I have an array and I want to know the relationship between multiple elements within that array, I should be thinking of 2 pointers, or, well, I guess in this case it would be 3 pointers, but the method of 2 pointers. And now, what I can do is, the way that you solve it is you sort the numbers, the array. So sorting the array. Now, why am I allowed to sort the array? This is one of the questions that I had. Remember how in the other problems, I wanted to know, like, the position of each element actually gave me information. Like the length, bing, 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 as I was radiating out. Or the width as I was radiating in, as I was coming in on the container. In both of those problems, the position that I was looking at actually gave information, either the width that told the volume or the length, which told how long that substring was. When you sort an array, you actually lose all of that information. But do I care about that? And the reason is, or the answer is no. The reason is because what do we actually want to output? We want to output this right here, where each set or each list is the actual values of the 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 actual values inside of nums. So like nums of I. I actually don't care about at what index it occurs. All I care about is this number in of itself. The other thing is like, okay, well, I does not equal j. So I do kind of care about like which index it is, but if I mix it up, all I need to figure out is this index does not equal the other index, right? Like as long as they're separate, we're good. So I'm able to sort it, and now that gives me information on what? Um, okay, so notice that the solution set cannot contain duplicate triplets. So that means that like -1, -1, and 2, I can't use this -1, -1, 2 again. So I can't have duplicate numbers, and so that's one of the things that sorting did. So that's another thing that I need to think about is that sort allows me to move to different elements in the list because I'm able to move my pointer 1 over until I no longer hit the same number, which I do right here. Yeah. And then this is just the standard normal two-sum problem. Okay, so now three-sum closest. This one I did almost very similarly, but instead of having a specific target that I was trying to get, instead of getting a specific 0, I was hitting a specific target. So this one, I just So this one, yeah, I did the exact same thing here, and then continued. So this one, I remember writing down in my notebook as well about the length of n minus 2. And so this was kind of like padding. And one of the points that I know that I need to try to practice more on is thinking about when a loop ends, like which condition do I want to end it on? Is it ending on the length? Is it ending on the length plus 1? Is it ending on the length minus 1? Is it like that's something that I need to go over and try to clarify it in my head more. And so then I find the difference, right? If the difference is closer, then I will update that information, and then I try to figure out like, okay, well, do I need to increase or decrease? Like which pointer do I need to move? And I I either move pointer 2 or pointer 3 because the pointer 1 is always going to be going along, and then my other ones are going to be like constricting based off of that pointer 1. So, okay, how do I move them? Well, if pointer 3 decreases, then that means because the array is sorted in ascending order, that means that the sum is going to decrease. So if my sum is already too high, I need to decrease it. That's what I do here. If my sum is too small, I need to increase it. And how do I do that? By pointer 2 moving over. So, let's see, I also started looking at this one, but I wasn't able to solve it yet. So it's this one here, and it is remove the nth node from a list. Now, okay, awesome. Here is another example of a two-sum problem, or a two-pointers problem. So it's a two-pointer problem, but it's dealing with linked lists. So I shouldn't have this thought in my head that if it's not an array, I can't use two pointers. I can. So in this one, some of the things that I'm stumbling on is like I have these three elements here. So like a scout, a soldier, and a lagger. And the idea is given a head of a linked list, remove the nth node from the end of the list and return its head. So what I'm thinking about doing is like saying, okay, well, if I want to remove the second to last element, so like this one, what I'm going to do is I'm going to let my scout go ahead 2 units. So it's going to, first the soldier is going to be here and the scout is going to be here. Then the scout is going to move over 1, 2, okay? So now what happens is the soldier and scout are kind of separated by 2 units. I'm going to have both of them move over until the scout hits the last element. Okay, and once the scout hits the last element, the soldier should be at the element that needs to be removed. Now, this, again, going back to what I just said about trying to figure out when my ending conditions are and stuff like that, like, okay, is it the scout goes over by the number of elements which I need to move, or is it like, so n is how many elements that it needs to move? Do I move the scout over n elements, or how should I position these units such that the scout and the soldier are on their respective locations? So it's something that I need to try to visualize and try to figure out, try to write down. But this is this is the problem that I'm working on right now. I'm going to try to solve this problem. I'm going to try to write it down more, and I'm going to try to keep going over these same problems until I get more of an intuitive understanding and feel for how these problems work and how to solve them, and I can solve them very quickly. So this is the progress that I made today. It felt kind of weird because I was I was literally in Amazon practicing to try to get into Amazon. It was a weird feeling. So I was in the Amazon building, okay, surrounded by a whole bunch of other software engineers, doing LeetCode on the weekend in specifically the Day One building, which is right by the Amazon Spheres. So I was practicing LeetCode in Amazon to try to get into Amazon. Yeah. But anyways, this is the progress that I made today. Hopefully I will be able to get better and better at this. I mean, I've been struggling with LeetCode for a very long time, and I'm just like trying any way that I can to improve. And so maybe this method will work. I'm going to try to continue to refine my methods. And yeah, so if that's interesting to you, subscribe to this channel. My name is Timothy Lee Grant, and I will see you guys soon.